So today topic atomic scattering factor, atomic scattering factor, or this is also called as form factor, scattering of X-rays, scattering of X-rays from point point scattering centers arranged on a space lattice on a space lattice are concerned. Next, second point, since an electron in the smallest scattering center the diffraction diffraction condition would be applicable. Diffraction condition would be applicable to a lattice in which a very lattice point is occupied by every lattice point is occupied by an electron an electron but lattice points but lattice points are occupied by an atom which has number of electrons So scattering of X-rays from point scattering centers arranged on a space lattice are concerned. Since an electron in the smallest scattering center, the diffraction condition would be applicable to a lattice in which every lattice point is occupied by an electron, but lattice points are occupied by an atom which has number of electrons. So which has number of electrons. Next point, the wavelength of wavelength of X-rays is of the order is of the order is of the order of atomic dimensions of atomic dimensions. The X-ray scattered the X-ray scattered from different portions of an atom of an atom are not in phase. Not in phase. The wavelength of X-rays is of the order of atomic dimensions. The X-rays scattered from different portions of an atom are not in phase. Thus the amplitude of thus the amplitude of thus the amplitude of radiation scattered by single atom may not be equal to may not be equal to product of amplitude of amplitude of product of amplitude of radiation and number of electrons Z. Number of electrons Z. Thus the amplitude of radiation scattered by single atom may not be equal to product of amplitude of radiation and number of electrons Z. Next definition. Definition. The atomic scattering factor the atomic scattering factor or atom factor F describes the scattering power of a scattering power of a single atom in relation to scattering power of single electron So what is the definition? The atomic scattering factor or atom factor F describes the scattering power of a single atom in relation to scattering power of single electron. So F equal to amplitude, F equal to amplitude scattered from an atom, scattered from an atom by amplitude factor, amplitude factor from an electron, from an electron. So F equal to amplitude scattered from an atom by amplitude factor from an electron. Here usually we can write F less than Z, it approaches it so usually it approaches to Z in limiting case, in limiting case. So next let us consider an atom. Next point, let us consider an atom, an atom containing electrons arranged in spherical symmetric configuration, spherical symmetric configuration around its center, which is taken as origin. So what we considering? Let us consider an atom containing electrons arranged in spherical symmetric configuration around its center, which is taken as origin. Let small r be the radius of atom, and rho of r is charge density, at point r, next let us consider a small volume dV at small r. The the change located at r is small r is dou of r into dv. So let us consider a small volume dv at r, at point r. So let us consider a small volume dv at r. The change located at small r is, we can take dou of r into dv. This is charge density into volume. Next. Next, let us consider the scattering from single electron O and the charge density at volume dv and n1 cap and n2 cap represents incident and scattered directions respectively. Scattered direction respectively. So let us consider the scattering from single electron O at O and the charge density at volume dV. So N1 and N2 represents incident and scattered directions respectively. Next, phase difference between the two waves. Phase difference between two waves.